Okay. So, so we have the seven layers, right? So can you just recall that what all the seven layers and what is the particularly every layer is doing?
Yeah. Uh, First, starting with the application layer. Application layer is like the physical, is that that layer which is interacting with the with the actual interface of the application.
Okay.
Um, I would say by giving some rules like protocols for the communication to happen.
Okay.
Okay, I actually remember from bottom physical layer, data link network transfer, physical data link network transport, session, presentation, application. Presentation layer will be used for doing the encryption
Okay.
for the application. If you want to do the encryption and then presentation layer is required. Also for reducing the size, if we want to reduce the size. Session layer is discussed when we want to, mm, in case there is a need for example, yesterday we saw for a website like Facebook, when we are interacting with Facebook, that means we are creating one kind of session with the application. So each interaction is a session. So for that reason, we need session layer. Now,
Mhm.
physical data link layer, network layer, transport layer. Transport layer is like the road you said. It will decide where we should how the transport happens, and depending on how the transport we want, if we want more security, we'll use TCP. If you want, uh, if you want more security, we'll use TCP. If you want fastness, we'll use UDP. Something like that. Physical layer, data link layer, then uh, network layer. I think in network layer, some protocols are there, IPv4 and IPv6.
Mhm.
Yeah, and then physical layer, data link layer. Uh, Data link layer is like L2 layer. L2 layer. In that L2 layer, I don't know exactly, but switches are there. And then physical layer, it is the medium for transporting data.
Okay. See, so number one is the presentation layer is not reducing the size. Okay, it is how we need to present our file or present our data. It will decide. See, for example, for one example, I already said you right. So if you are developing an application, so for example, inside your company or something, you are developing application, you are just design your GUI everything into the something in the monitor level. So you are using some 16-inch monitor, 20-inch monitor, something. But at the same time, okay, that same application, if they are running in a mobile, okay, so that UI will automatically change. Okay, not like, so it will fit to that our window, like it will fit to the mobile window. Okay, so that will take care on the presentation layer. It's not reducing the size, it is the way how the presenting the data or how the presenting the file or
Okay,
something.
adjust basically.
Correct. So that is a one thing. Okay, and then yeah, transport layer is fine. Network layer, yeah, it's IPv4 and IPv6 is a protocol. Okay, so they and that particular protocol is working under the layer. But what is happening in that layer is actually dividing the data into that IP packets. Okay, for example, if you are sending some data, for example, if you are sending if in the application layer you are entering your mail ID and password and then other data. Okay, inside the network layer all the data will converted into the IP packets. Okay, so multiple packets, for example, Eshwara at gmail.com will convert into the 20 packets. Password admin 123 is converted into the 10 packets. So Every packet will convert into the every data will convert into the packets. Okay. So each packet will have a three portion. One is header and one is tail and one is payload. Header is nothing but a source IP address and destination IP address. Who is what is my IP address and what is my receiver and the IP address. So it will map. Then tail means the version, what is IP version they are using, what is the flags, and we have a multiple details is there. So all the details will have in the particular tail information. And then payload is the actual message. So this information will have in that IP packets. Okay. Then once it will come to the data link layer, yes, correct. The data link inside the data link layer, the switch is working. But the switch is a device, it's not a process. Okay. What happened in the process inside in that particular IP packets? Okay, there is a no nothing with the sequence number and all. Okay, what is the first packet? What is the second packet? What is the third packet? So it um if the packet will send to that medium, that means air medium or wired medium in the direct way, it will collapse. Okay, once it's receiving in the receiver end, okay, it may be collapse. Like first packet will send first packet received in the last packet will receive in the first. So the receiver end it will be it's not proper way. So inside the data link layer, so the IP packets, so this IP packets will framed. Okay, one of the frame is attached. So inside the frame there is a sequence number will return. So this is the first packet, second packet, third packet, and all. And then it will map the MAC address of the device. So this is my physical IP of the device. So that is also mapped. So these two process will happening in the data link layer. Then physical layer is actually the
So
medium. So
in the data link layer, one thing is MAC address is mapped. Second thing,
correct. Sequence number, frame, either that IP packet will be frame. So for example, the photo frame. Okay. So that photo is the actual data. So for the safety purpose, we need to frame. Correct. The same thing happen in the that IP packets will be framed. Okay, inside the frame there is a sequence number. This is the first packet. This is the second packet. So Eshwaramurthy at gmail.com means E is the first packet, S is the second packet, W is the third packet. So at the receiver end, once it's received, okay, based on the sequence number, it will reorder the all the packets. Once it's received all the packet, okay, what is the first packet? E is the first packet. Yeah, what is the second packet? S is the second packet. W is the third packet. So it will rearrange all the things and it will uh, bring the all the message together, okay, as the same order.
okay. And
You
this
get
will
my point.
happen at the receiver end of the data link layer.
Which one? The sender end it will be framed. Okay, it will add a sequence number. In the receiver end it will rearrange the order. For example, okay, I'll show you.
Yeah,
So
so in the while sending, it will create the frame and give the numbering, and at the receiver end, when it receives, it just keeps in order after it
correct.
has been numbered. Okay, okay.
Okay. So this is what happening in the data link layer. Okay, and physical layer is as you said, it's a abundant. It's not only the medium; it will convert the ones and zeros that normal data data into the ones and zeros bit format. Okay, so the computer will only understand the ones and zeros, right? So it will convert the ones and zeros that medium, and then it will forward the traffic to the air medium or wired medium or something. So that is how the flow is happen. Okay. Now any doubts so far?
In network layer, what is happening is just the packets are being created.
Correct.
Okay.
Packet is being created and it will label the source IP address and destination IP address, tail information, and the actual data. That's all. Okay.
Each
So
each packet will have that information you're saying, right? Source IP, destination IP, and source IP address, destination IP address in the tail.
correct. So
Okay.
tail information we have multiple things like see if you go for the IP packet information. We have these much of information will be there. Version, if it's using the IPv4 or V6, okay, what kind of service, what is the total length of the packet. So yeah, now we have a time to live protocols, so every information we have. So this is a source and destination IP address. This is a head information. So this is a payload. So this is how it should be. So that whole packet will be, it's a, like a 32-bit, I guess. IP packets means the 32-bit. So this is how that IP packet will be formed. And so that's all for that OSA layer. And did you check that what are the protocols we are using inside the every layer?
No, I was able to do just transport layer thing. So not this thing for this one, but for transport layer and network layer, I got to know IPv4, IPv6, and this is TCP UDP. And application is HTTP, that we are using. I'm aware of that. Yeah, I did not get to see for the others as well.
Okay, just check today. Fine. So in this, as you said, the transport layer, we have two protocols. One is TCP and one is UDP. Okay.
Yeah,
And you already said the 1 or 2 points for the difference between the TCP and UDP, right? So
yeah.
have you? So what do you know about the TCP and UDP?
So I think transport control protocol and user datagram protocol.
Okay.
If we want more security, then
Mm-hmm.
the user must choose TCP protocol. And if you want if you want more security, then use TCP. And if you want
Mm-hmm.
more fastness, then use UDP. So, for example, for YouTube video streaming, they'll use UDP, but for banking applications, they'll use TCP.
Okay.
Uh,
So concept wise correct. Okay. So the TCP and UDP, it's a completely opposite protocols. Okay. So TCP, as you said, is a secure. Okay. Why it is called secure? What is the principles it follow? Okay. Why it should be secure? Okay. So TCP will follow one process called three-way handshake process. Okay, three-way handshake process. What is happening in the three-way handshake process? So if we have a source and destination system, okay, we have a source and we have a destination. Okay, so this source and destination is going to transfer some data. Okay, the source is myself and destination is yourself in that case. Okay, we are going to share some data. Okay, but before sharing the actual data, we need to know each other. Correct.
okay,
So
okay,
for,
yeah, yeah. Hmm.
okay, so for that, first of all, the sender will send one packet called synchronized packet. Okay,
Isn't it
say
ACK? Isn't it ACK the first packet? Think I remember this. ACK first, no?
ACK is acknowledgement, that's the second packet.
Okay.
Okay, first it will send the synchronized packet. Okay, so once the receiver system, that means the system B will receive the sync packet. Okay, it will send the acknowledgement. Okay, that means so I'll receive your packet. Okay, so A will ensure if I send some message to B, that particular message will go to that will reach. Okay, so it will get that acknowledgement. And this B also want to introduce themselves, right? So for that, it will also send the sync packet.
Okay, yeah, yeah.
At the same time, it will send the sync packet. Okay. So once the system A will receive the sync packet and it will send the acknowledgement. Okay. So now both can understand. Okay. Both can know each other. Okay. Both can ensure that if I sending the message, it will reach to the destination. Okay. Now it is starting to send the actual message. Okay. For example, if I'm going to send the 100 packets, okay, 100 packets in the sense of any data. So it will convert into packets and all, right? So if I going to send that 100 packets, okay, each packet I need to get the response. That means each packet I need to get the acknowledgement. For example, okay, first packet I will get the acknowledgement. Second packet I will get the acknowledgement. Third packet I will get the acknowledgement. If, for example, so in between that, in the meantime, okay, there is some issue in the some minor glitch is happening. Okay, so the 65th packet is dropped. Okay, any packet, I'll just take an example. So 65 65 65th packet will be dropped. Okay, so the receiver is not sending the acknowledgement for the 65th packet, but is starting to send the acknowledgement of 66 and 67, 68, something like that, and 100 packets. Okay, so the sender will think, okay, this I don't get the acknowledgement for the 65th packet, so there is some issue maybe, so I need to resend that particular packet. So this particular sender will send the 65th packet, and then this time it will get the acknowledgement, then it will close the connection. Okay, this is not a user anything with the user, this is automatically will happen behind the scenes. Okay, so it's automated, so it will send the that means a failed packet, so it will get the acknowledgement and then it will close the connection. So once it will get the acknowledgement for the all the packets, then only it will close the connection. Okay, so this is how we can ensure that, okay, all packets is received by user, all packets is safely sent to that particular in the channel, so we can ensure all this. Okay, so this is
Uh,
the process.
yeah.
Yeah.
So, for example, in this case, when TCP is being used, this three-way handshake is established. First, SYN packet is sent, then SYN plus acknowledgement, then acknowledgement is sent. After that,
Hmm.
A can start communicating with B. So, for
Correct.
each packet that is sent by A, B has to send the acknowledgement.
Correct.
Okay, so ACK packet is sent by B for each packet sent by A.
Correct.
Okay. Yes.
For every packet, that B will send the acknowledgement.
Okay, and for acknowledgement on receivement, A will resend it.
Correct.
Okay.
Okay, so this is the process this TCP will follow. So due to this, we are saying it's a secure protocol, because we can ensure that that packet is not anything modified in between, that packet is not a malfunctioned or anything. Okay, so whatever I send to that the receiver, I send to that particular person, I can ensure that it will be delivered as it is. Okay, so this is a secure protocol, and this is also the reliable protocol. Okay, so again the same thing. Okay, so compared to user datagram, it's a slow convergence. So this is also the speed, so we don't see any difference and all, but it's a slow convergence protocol. Okay, and coming to that UDP, it's exactly opposite. Okay, this is not follow anything with the the three-way handshake or something. Okay, it okay, it will not send any sync acknowledgement, etc., etc. It will only send the packet. Okay, it will not take care of whether it's the system B is receiving or not, anything. So it will directly send the messages. Okay, so that is the reason. Okay, this is called as a fast convergence. Okay, because there is a no need for anything to wait for acknowledgement or something. So it will only send the packets. Okay, but it's not a security, it's not a reliable, but it's converted into the fast convergence. Okay, so it's exactly opposite. Okay, and the example which you said is mostly correct, but I'm saying like a YouTube is not a UDP. Okay, YouTube is also the YouTube is also working in the HTTPS protocols, that is comes under the TCP. Okay, so the TCP we can say like a, anything like a messaging application, YouTube, Google, YouTube, whatever, HTTP, HTTPS, anything. User datagram protocols example is video calls, we can say, or a live streaming website, Hotstar, something. So that is using that inside the YouTube. If you are seeing some live streaming, then it should be use the UDP. Otherwise, it choose the TCP only. Okay. So for example, video calls. For example, if we are both are we are talking in the video call. Okay. For example, there is a some minor glitch in my network. Okay. So for 1 or 2, for example, for 10 seconds, I'm not able to hear you. Okay. Then after 10 seconds, my internet has recovered back, and that particular time and that particular 11th seconds what you are talking only I will receive. Okay, because in between the 10 seconds we don't have any, I don't have received that information, right? So that time it will not send back and all. Okay, so at that time what is happening, that is only the thing we are receiving. So that is the reason for we are using the user datagram protocol. So video calls, live streaming websites, they are using the UDP protocols. You get my point?
Video call and live streaming. But what about YouTube? You said YouTube is using HTTP, but here we are not talking about application layer protocol, right?
Okay. See, inside the YouTube, if you are watching the pre-recorded videos, okay, that is working under the TCP, TCP things. Okay. If you are watching something a live streaming, then that will use the UDP. You get my point?
But why can't they use UDP for pre-recorded videos on YouTube? Because fast play, right?
Okay, if it's something like that, okay, if you are inside, so that if you are watching something, okay, so just imagine, okay, if you are watching something, okay, you have glitch in your internet, okay, so that YouTube will load, okay, after 10 seconds or 15 seconds, it will play back where you are stopped, right? So if they are using the user datagram protocols, how it should be like it will directly go to the, for example, in the 10 seconds there is a something happening, it will go for the 11th seconds. It is not happening inside the YouTube pre-recorded videos, right? So if there isn't something glitch is there, so it will load, it will buffer, and then once it's recovered back, it will start with us where it is stopped.
Okay.
So that is a difference. Okay, if it's a live streaming something, you are seeing some news live channels or something, that is completely different. Okay, if you are if it's something like a buffering, and then after 1 minute or 2 minutes it's recovered back, okay, then what is that at that particular time what is happening, you will see that particular information only.
Okay.
Okay, so it is the difference actually. Okay, and so that is also, and that we are not as a user, we are not choosing we are going to use a TCP or UDP. Automatically the protocols will decide which one we are already the defaultly the protocols will decide which protocols they are using. Okay, for example, if you are saying the TCP, we have a HTTP, HTTPS, SMTP, etc, etc. We have multiple protocols. And if for UDP, bias, and some other protocols like streamings, database applications we can have. So this is something. So this two is actually the important. So OSL is one of the important topic, and this TCP difference between the TCP and UDP is also the important topic. Okay, so every times they will ask if you are fresher or if you are then the beginning of the networking career. So they will repeatedly it will ask what is TCP, what is UDP, what is the difference between the TCP and UDP, then what is a three-way handshake process. Okay, then what is a real-time example for the TCP and UDP. This is all they will ask.
Oh,
Okay, so okay, so this OSI layer and TCP UDP is a logical flow of the packets, correct? So now we are going to see for the physical architectures. So how our data center, how our network devices need to design, or what is the architecture, what is the overall architectures we need to follow. Okay. There is a three architecture types. Okay, one is two-tier architecture, and one is three-tier architecture, and third one is spine leaf architecture. Okay, so do you have any idea about this two-tier, three-tier, and spine? Spine maybe not. What is any idea about what is two-tier and three-tier?
No, not exactly.
Okay, so simple. In the two-tier and three-tier is a simple as same in the word. In the two-tier architecture, only 2% is there. Okay, three-tier we have a 3%. Okay, so we have two types. Okay, one we can say like a two-tier and three-tier architecture as a software development side. That means application side and also the networking side. There is a two different things is there. Two-tier means okay, if you are in the software development side, two-tier means the client will directly access to the database application. Client will directly access to the database. Okay, so the client is a one person, database is a second person. Okay, for example, if you see like a excel sheet or something like you can say like a telephone directory. Okay, the telephone directory is a complete database. So if you want to search any number, you need to go to that particular telephone directory. You need to search by one. Okay, if you want to search the issues, so then you need to start with this A, then you complete B, then C, then D, then E, you will find out the issues name. So the client is directly accessing to the database. So this is the two-tier architecture. Okay, this is for the software development side. I will come to the network side. Okay, if it's a three-tier architecture, in between there is a one person. Okay, we called as a web application. Okay, so okay, inside the web application, I have some page called. So there is a search box. Okay, if you give some any number, that means any name and the search button. Okay, so this client will enter the information in the web application. Okay, so the web application will direct access to the database and the search for that name, and then it will display the username, and then the database will reply to that web application. Web application will respond to the client. So this is called a three-tier architecture. What is the difference between two-tier and three-tier? So two-tier is a very simple, okay, direct access. There is a no need of the third person, okay, but it's not a secure and it's a long process. So when using the web application, that means a three-tier architecture, it is secure and it is completely fast. So compared to that, it will fast. Okay, so this is come to the software development side. Coming to that networking side, the same thing is happening. Okay, that inside the two tier we have only two persons. Okay, in the three tier we have a three person. Okay, so two tier we have a core and distribution layer at the same device. Okay, what is the core and what is the distribution? Core is something is directly connected to the outside the network. Okay, if some device, okay, is accessing or is connecting to the outside the network, okay, so that is responsible for communication between the so from LAN to WAN, that is called as a core layer.
Just a moment, sorry.
Yeah.
I understood till the last point, which you were saying about three-tier architecture and two-tier architecture, client,
Mhm.
business, database, and then application. What is this you're talking about? Can you please repeat?
So this is also the same two tier and three tier architectures, but in the networking side, okay, or in
So
the
this
data
is
center side.
so this is fine leaf or this is same
No, no.
two-tier, three-tier,
Same
but
time. This is also the same two tier. See, the whatever I discussed before, okay, that is a software development side. If you are a software developer, you are running. So inside your developing process, if you are following the two tier or three tier, so that is completely different. Okay, that is for the software development side. Okay, the same thing we are going to follow inside the data center as well, the two tier and three tier. So inside the two tier in the data centers, instead of the client, we are saying as a core layer. Instead of that database, we are saying as a access layer. Okay,
okay.
so naming is different. Or else, okay, just completely forgot about the software development side. We can focus on the networking side. Okay, so don't confuse yourself. Okay, so this is also the two tier architecture. So whatever I'm Currently I'm drawing something. So this is a two-tier architectures.
Okay. But this is in server, right?
Correct. It's not a server, it's a network that devices.
Oh, then you said server, right? That is in software and this is in server.
No, 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 no. See, again, so whatever we discussed previously, that is for the software development side. It's
Yeah.
completely forgot. Don't We don't want that actually. We completely
Okay.
forgot. So
Okay.
currently we are following the two-tier architecture for the networking side. Okay.
Okay.
Inside the networking, okay, the two-tier means we have a two layers. One is core and distribution. Okay. Second layer is access layer. Okay.
System core or distribution. Next is access layer.
Not a core or distribution, core and distribution.
Okay.
Okay. So what is the core layer means? Okay, if something directly connected to the, that means it's a connecting to the LAN to WAN, that is called a core layer. Okay, what is distribution? Distributing the packets. For example, inside our LAN, we can have a multiple networks. For example, production zone is there, testing zone is there, UA zone, that means QA zone is there, and then enterprise zone is there. So we have a different zones, right? So inside the company, we can use a different teams and also. So distributing the packet as per the needs. Okay, so that is called as a distribution layer, distribution things. Access layer means last layer which is directly connected to the inside the that particular zone, directly connected to the host machine. Okay, so let me explain. Okay, so the core and distribution, okay, in the two-tier architecture, core and distribution will be on the same device. Okay, same device. How? I have one router. Okay, so that router is directly connected to the internet. Okay, that router is connected to the one switch. Okay, the switch is connected to the host machine. Okay, inside the host machine we have a these two machines for the production, these two machines for the QA something. Okay, so I have some small setup. Okay, the company is very small. Okay, so my company router, so I have a very small network, I have very small use, a small number of users. Okay, in this case my exact that one routers can able to handle both process, core and distribution. This is also taken care of the LAN to WAN connectivity, and also it will distribute the packets. Okay, so inside the two-tier architectures, the core and distribution will be in the same layer. That means the same device. Okay, what is the advantage? Very easy to implement. Okay, because there is a no design pop. There is a such a huge design and all, so it's easy to implement. Okay, but disadvantage is it will suitable for the small company, small networks. Okay, so if you are going to that three-way, that is sorry, three-tier architecture, okay, this core and distribution will split into the different devices. So core, I have a one switch, okay, and then I have a one distribution switch. Okay, this is something like a main switch. Okay, something like a data center switches like Nexus or something. Okay, then I have a access layer. That means a access switch. So this core layer only taken care of the connectivity. That means a WAN connectivity. Okay, it will not distribute the packets. Okay, whatever the connection, it will just forward to the this particular data center, so DC switch. Okay, this DC switch will take care of the decision. Okay, so someone from outside is trying to access our production zone server. So it will forward the traffic to the production switch. That means this particular switch. So someone is trying to access our enterprise zone. So this is here. So someone is accessing the QA zone. This is here. So this particular distribution of the packets will be taken care in the this particular DC switch. Okay, why I want to split? Okay, so in the larger network, okay, I don't want to push all the tasks to the every single device. Okay, then the device will be the performance will be degraded. So I will say, hey router, you will take care of only the connectivity between the LAN and WAN. Okay, I don't want to push all the things to you. Okay, you can only take care of this connectivity. Okay, whatever that outside person asking, just forward the packet to the DC switch. Okay, so the DC switch, I will say, hey DC, you will only take care of the distributing the packets. You don't worry about this LAN to WAN connectivity. That is will take care by the router. Okay, you will just distributing the packet. So whatever the routers ask, just distributing the packet to the particular switch. So if it's something like a production, so this DC switch will directly send to the production access layer switch. Okay, this is normal L2 switches we can say. So here we can have a servers. So this servers will have so productions applications and all, and then it will respond to that switch. The switch will respond to the DC. That means the DC switch. DC switch will respond to the router. Router will get to the particular user. So we have a three devices here dedicated for core. One is for distribution. One is for access. This is called three-way handshake method. Three-tier architecture. Okay. In the two-tier architecture, this core and distribution will be in the same device, and three-tier architecture, both are different device. You get my point? Any doubts?
Core plus distribution separate. So in the two-tier architecture, if we go back to the two-tier architecture, basically it's consisting in network two parts, right? One part is core and distribution, and the other part is access.
Correct.
So core and distribution is responsible for taking the data and just forwarding it, right?
Uh, Come again. Come again. Sorry.
So core and distribution, it is responsible for just taking the data and forwarding it. Or is it following any rules?
Okay. In the two-tier architecture, the first layer, that means the core layer, will take care of both process connectivity and also the distributing the packets. Distributing in the sense of, see, so inside the company, you will have the
So
different,
distributing means it is also doing the job of the distribution layer.
correct,
Okay. So there are no core and distribution layer then. It is just a one core layer that is doing both
correct,
core plus distribution.
correct.
Okay. And job for access layer.
Access layer is just forwarding the packet. Access layer is the direct connected to the host machine. Okay. For example, if you are in the production zone, okay, so from this particular DC switch or direct router, whatever. Okay. So it need to get the connection, and then it is a L2 switches. Just the L2 switches, it will just broadcast the packet. That means it will forward the packet to the host machine. Okay. Access layer, we don't have any decisions and all. It will just get that packet and forward the packet. That's all.
Okay. So why is there need for access layer? Why can't core layer directly distribute it?
So if I connected
In,
all the
in, in two
production servers,
in two-tier architecture, I'm talking about.
how you can connect all the servers to the single router. So routers having just minimal ports. For example, we have a four ports. You can guess. I have a 50 servers, okay, or 50 host machine, 10 for production, 10 for QA, and 10 for some other office servers and all, etc. Okay. If I have a 50 host machine, that means 50 machine, how you can connect all the 50 machine to the direct to the router.
Okay, just like how we need switch, just like that over here as well, right?
Correct. Switch is the access layer. Again, I'm saying, right. So from whatever we are getting from that router, if you are in the two tier, whatever you are getting from the router, it need to forward. Okay, it will get the packets and it will forward to the specific zone. That's all. So if you are in the L3, that means that the three-tier architecture, okay, this DC will distributing the traffic. That means it will, for example, it should be the DC switch. Okay, it will be the high specification. It will forward that. Okay, if it's a QA zone, send to this particular. So this QA and will production will not interfere. So if someone is attacking that QA, it will not affect the production. If someone is attacking or if something violating this any other zone, it will not affect the production zone or any other zone. That is called a distributing.
Okay.
So this is for three-tier architectures. And coming to the spine leaf architectures, okay, in this whole two-tier and three-tier, okay, there is a one device taking care of two things. Okay. So core distribution is a split, that's fine, but every single device is taking care of two process. One is storing the information. Okay. Whatever you are giving some configurations or memory or so whatever it should be. Okay. So it need to store such information. For example, inside the DC, what are the information are stored? If someone is asking for the production, I need to forward the traffic in this particular interface. That information can be stored. If someone is wants to connect to the enterprise zone, I need to forward the connection in this interface. And then QA means this interface. So this kind of information is storing. So for the router, so if someone wants to connect to the any of this network, I need to forward to the this particular DC switch. Okay, and other informations, etc. So storing the information is the one task, and then forwarding. So based on the storing information, it will forward the data. Okay, simple I can say. Okay, I am the device. Okay, I am the router. Okay, you are coming to me. Okay, you are giving just your visiting card. Okay, so I will just take that and I will store it in my pocket. Okay, storing the information. The same time, everyone, that means 100 persons came to me, 100 persons will give the visiting card, and every visiting card I will take and I will store the information in my pocket. So in my pocket there is a 100 visiting card is there. So that is the data. Okay, now one person came and asked for the, can you give the Mustafa details? Okay, so I need to take that visiting card, I need to give the information. So I am doing some processing, forwarding the information. Okay, I'll forwarding the Mustafa's information to the someone. Okay, so I am taking care of two process. Okay, if every device, okay, if taking care of storing and processing the data, okay, if it's taking care of two particular work, definitely it should be something like a slow. Okay, compared to other things. Now, coming to the spine leaf architecture. Okay, the spine leaf architecture, spine is the core switch. Okay, leaf is the like a we can say like a subordinate or something. So something like a assistant. So now I am the core device. Okay, I have a two assistants. Okay, now the same process is happening. Mustafa is coming. Okay, giving the visiting card. Instead of storing it in my pocket, I am giving to my assistant. Okay, I'll just say like a assistants, just store the data. Okay, then again the 100 persons came, 100 persons will give the visiting card. I will split the data into the two of my assistants. I will one person will store the 50 and one person will store the 50. So storing the information now is not in my task, it's in my assistance. Okay, so that last person came, that means one not one person came, ask for the Mustafa details. I am not storing the data, so simply I can put my assistant packet and get the data and I'll give to them. So now my job is only one thing, is a processing the data. Okay, forwarding the package. I am not responsible for storing the data. Okay, so when you compare to the three-tier architectures, the spine leaf architecture will be faster. Okay, because storing the information is my assistance. I am just forwarding the information. Okay, so this is spine, this is leaf. Okay, are you able to get my point? No.
Um, in earlier architectures, uh, also it was the same, right? We were not storing the data, but once the data came, we were forwarding it to the respective networks. Okay, what's the difference here when compared to that?
How in that previous architectures and all, I am responsible for storing the data as well as I am responsible for sharing the data.
Yes.
Okay, if you're so if it's a router, it's a three-tier architecture. If it's a router, okay, the router will have the information as well. What kind of information? If someone is asked for that Mustafa, I need to forward the traffic in this particular interface. If someone is asking this another network, that means a QA zone, I need to forward the traffic to the that interface. If someone is asking for that enterprise zone, I need to forward the traffic to the other interface, and other informations like routing protocols, um, um, route information, everything will be stored inside the router only.
Okay.
Correct. And
Okay.
also, based on the information, the router will forward the traffic as well. Okay, so the two processes happening. So here, okay, and the same for the DC switch as well. DC switch is also storing some information. Based on the information only, it will forward the connection. But here, spine is different, leaf is different. Okay, but again saying this all under the one device but two chips. So inside the architecture, okay, so inside the chip level, they are creating the spine switch and the leaf switch and all, but it's everything comes under the only one device, which is called as a Nexus 9000 series. I'll share you the story. Okay, so but architecture wise, it's a different switch. So physically it's a single switch, virtually it's a two, I can say like that.
Yeah, but how
Okay.
can Leaf take the action without Spine actually directing the data to the Leaf? Because even Spine has to direct the data to the Leaf, right? It cannot just forward as it comes.
I didn't get you. See, spine and leaf all in like how to say, um like a brothers and all. Okay, so we have designed something like that. Okay, so compared to the three-tier architectures, okay, we have used some softwares, or if you're using some coding, so the spine and leaf are uh, having a good connections, or I can say like a, it's well bind actually. So
Yeah, like coordination they're having, some kind of like,
correct.
okay.
It's a design wise, I can say like a
But
so compared to the
even if Leaf is like a servant, Spine has to send some messages, right? Spine has to give the direction. It cannot just forward all the data to Leaf. If it is forwarding all the data to Leaf and telling him them to take a decision, then what's the point of Spine?
leaf is not taking the decision at all. Leaf is only for the storing information.
Okay.
Okay, see, if that's what I'm saying. If some first persons came and give me the information, okay, I, instead of me storing the information, I will give to the assistants. Okay, if the last person came ask for the Mustafa details, leaf is not going to respond to them. I am going to respond to them. As a spine, I am going to respond to them. I will get the information from that my assistant pocket, and they will give the information. That's all. So leaf is only for storing the data.
Okay. And spine will actually do the processing and give the data,
Correct.
right?
Correct.
Okay.
Okay. So that last one point before we complete, okay, where we are using this spine leaf architecture now. Okay. So this is the trending technology inside the network industry. We have a one technology called ACI, application centric infrastructure. Okay. So this is a one of the technology currently we are using inside the data centers. Okay. This is this particular feature only we can enable in the only one product which is called Nexus 9K series of switches. Okay, it's a data center switch. Okay, Cisco product. Okay, it will cost like a, this switch will cost like a more than 25 lakhs or something. Okay, so in the single switch only we can enable this product. That means that this features. In these features we are using this spine leaf architecture. Okay, not only the spine leaf architectures, we have a n number of features inside the ACI. Okay, so if you are good in networking, as a, so for example, you have some experience in networking for 4 years or 5 years, if you want to pursue something more, then you can go for the ACI. Okay, but if you're initially talking, then everything will be just like confusing and all, Greek and Latin. So if you're getting the experience, you can go for the ACA. Okay. So this is the one thing we are using now. Okay. So now
So apart
today,
from the spine leaf, ACI is the trending one, right?
okay, ACA is ACA is a domain or ACA is a feature. Inside the features, we are using this architecture.
Okay.
Okay. So this ACI will come up with only this device. Okay. First, if you want to use the ACI, you need to buy this device. Then you need to enable this ACI. So inside the ACI, we are using the architecture. This is a flow. Okay. So let me summarize. We are talking about two tier, three tier, and ACI. Sorry, that is spine leaf architecture. So that is the architecture we have discussed. So tomorrow we'll start with this other topics.
Okay.
Okay. So that's all for today, and we can wind.
All right. Okay. Thank you for
Bye bye.
the
Yeah. Bye.